Hi, and welcome to this very quick lecture we've got. Most of it's to do with doing the reading that's recommended from the textbook and watching the YouTube videos I've added at the bottom of Week 4's Moodle tab. They explain it quite well in several different ways. Looking at network analysis, doing it through a critical path method on this example. Next week we'll have a look at a PERT example, Program Evaluation Review Technique. The difference between the two is a critical path method only uses one time estimate, whereas a PERT uses 3 time estimates. So you get a bit of uncertainty in that one, and there's a tiny bit of statistics in that as well, but not bad statistics because I'm not good at them either. So let's just have a look and try and work our way through this. So through a network analysis, the steps to produce a network, and you've probably seen this, I hope anyway, you have to list the activities. That you've got to determine whether you want to use an arrow methodology or an arrow on node methodology. They're explained previously and in the textbook. And the activities are broken down, so imagine you're building a house. You'll be from setting out the site to levelling it off, to excavating, to pouring the concrete footings, pouring the slab, levelling the slab, putting the frame up, everything in the order it has to take place. Now there obviously are activities that can take place at the same time as each other, but generally activities are dependent on something finishing first, their predecessor. So we need to be able to work these out logically. So we need to show in the network the logical relationship between the activities. Okay. Sometimes I will admit some of the relationships may not seem logical on big projects, but we're keeping it nice and simple for this. And then once you've listed your activities in the correct order, in a tabulated form you'll see in a second, we have to make an assessment of the duration of each activity. So we can produce a schedule and we can work out then the start and the finish times of every individual activity. We do it 2 ways. We do a forward and a backward pass just as a check on each other, and we identify if there's any float available, any sort of additional time that's there we can play with. And we can also assess the resources that are required. Just note at the bottom of the float, or sometimes it's called slack, is the amount of time a task in a project network can be delayed without delaying the final completion or the project completion date. And there's an example of that in one of the examples we're coming up with. The benefits of a network analysis, they're quite useful for quick planning. I would point out that most of these tools actually work through Microsoft Project as well, so you don't have to do these individually. So planning, we can identify all the tasks necessary to complete a project. It's a good cross-reference and a check on yourself that you've not forgotten something, and it's so easily done. I once had a project refurbishing a terrace of Victorian houses for a social housing provider. And we did everything. We gutted them, we completely rebuilt them, we insulated them, we put new central heating in, everything. Except I forgot the boiler. And luckily I was on good terms with the contractor, so we managed to work that out with the contingency. Really obvious thing to forget, so don't think you're not going to do it. We need to be able to identify the really critical activities, and also the activities where there's a bit of leeway, a bit of padding, a float or slack. We can set deadlines to work towards, so we can have set dates that we have to achieve, and we can work those out through the analysis. Analysis also helps you plan the ordering of your materials, your equipment, your labour. We always want those to be just in time, so we haven't got money out of our control and out of our bank account sitting in someone else's. We always want to pay as late as possible. Start and finish times, and you've got to remember these. So these are things you've got to really remember. They do come out in the quiz you've got later on. They're necessary in the assignments as well. So the earliest time that an event can start. The ES, the earliest time, is the earliest possible time an activity can start. Oh, that's repeating ourselves a bit, but it's what it is. The earliest time of finish, EF, is the earliest time that a succeeding, a following activity can start. Obviously, the following activity can't start until the predecessor finishes. You can't build the walls until the foundations are done. At the latest time of start, LS, is the latest time an activity can finish without delaying the completion of the project. And if we know those times, then we can work out, we can calculate what the float is, what our little padding is where we can have a few weeks here and there. So this is just arrow on node, or sorry, activity on the node example. There's our little flow chart. So we have a start, and I'll mention it at this point here because we're working times out, and when you see the durations in a minute, they're all in weeks. So start is always week 0. Okay, it's always 0. And you can see activity A and B can start together. Activity C cannot commence until activity A and activity B are completed and follow through the same way. Instead of just putting a little round blob, a node or a square, we use this little box here, which has got all those time elements in it. So it's got the earliest start and the latest start, and it's got the earliest finish and the latest finish. It's got the duration of the activity, whether it takes 3 weeks, 10 weeks, whatever. That's the duration, and that's the identifier. In the example above, that would be A, B, C, D, E, F. We're going to use 1, 2, 3 in a second. So an activity on the arrow. So we've got the earliest possible start time is 2, the latest is 2, but then we've got the earliest possible time there is 9 and 11, the latest. So we go from activity 2 to 4, a duration of 3. So let's start doing an example. There's your basic activity schedule. Notice it's only got one time, one duration column, whereas I said the PERT will have 3. So we've got durations in weeks. So activity 1 has no predecessor. Okay, it's the start. It takes 3 weeks. Then activity 2 can't start until activity 1's finished, and activity 2 takes 3 weeks, and so on. When you get to 5, 5 cannot start until 4 and 3 are finished. So you have to have 4 and 3 finished before 5 can start. And that will show up in the flow chart. I'll pop that up every time just to remind you. Just to remind you again. So now we need to draw a logical diagram and put the activities in. There's the same chart we saw before with the same numbers on it. And here's the network we've drawn out. So we have a start, then activity 1, and you can see we haven't filled in the early start, late finish, all that yet. All we've got in is the activity identifier, which is 1, and the duration is 3, that comes from the table above. Then you go to activity 2, that's a duration of 3. Activity 4, duration of 8, and you can see how they're written down there. So if we were to calculate up our critical path, shall we say, where's my pointer gone? Here we go. So we have to do 1, then we have to do 2, and we have to do 3. So they're parallel to each other. So 3 looks shorter because it can shoot straight across the 5. But 5 can't start until 4's finished. So you have to go 2, 4, then 5. So if we take this one here, and you can see just down here, critical path can be seen as being 1, 2, 4, and 5. So if you add up 3, 3, 8, 4, you get 18 weeks. Now if you think you can go and do it this way, you'd have 3, 6 and 4, which is 13 weeks. Doesn't work. We take the longest time, which means our critical path is actually that. Sorry, and to finish. That's actually our critical path. Now to do a forward pass, very simple mathematics required on a forward pass, is to determine, we're trying to work out the earliest start and the earliest finish of each individual node or activity. And we do it from the start all the way to the finish. So for example, if we take activity 1, now the earliest start is based on the start. And we always said the time for a start is a 0, so it has to be 0. We know the duration of activity 1 is 3, so 0 plus 3 is 3. So the earliest finish is 3. And we just do that as we go along. So let's go up to activity 2. The earliest start for activity 2 is when 1 is finished, which is 3. So 3 goes in here. The duration is 3. So 3 plus 3 equals a finish at 6 weeks. These are weeks, remember? 6 weeks. So that then goes here. So the earliest start for 4 has to be when 2's finished. So that's 6. 6 plus the duration of 8 gives you 14. And then to the last one, 5. It can't start until this finishes, so that 14 is the early start there, plus its duration of 4 gives you 18 weeks. Do it the other way, and you end up with 3, so it can't start before then, so it has to be the 3, plus the 6 duration of this. 3 plus 6 is 9. And you would say 9 goes here, but it can't do, because this can't start until that one's finished. So we have to keep the higher number 14. So our critical path is the same as on the last one, with the duration for the whole project of 18. Now, here we see that activity 3, has a start of week 3 because of this. But there's nothing after it until week 14. So in theory, you can move this activity backwards and forwards. You can relocate it. The resources that are here in week 3 may be useful up here. So this could be pushed out and you could work on this one. All that matters for this is it finishes on the 14 week. Sorry, not 14, 18 week. Sorry, even I got it wrong. So you can do the same. It's fiddly, but it does work, I think, in project. I think it's got this. Now, that was the forward pass going that way. Now, this is the backward pass going that way. We're going to the left now. And this is a check. So it's the opposite of what we did. So we know here that the finish time is 18. So here it is here. For activity 5, the latest finish is equal to the earliest finish, which is 18. And the latest start is equal to the latest finish minus the duration. So that's 18 minus the duration gives us 14. And it adjusts the numbers on the way back. And when you get back to here, it should always come to 0 as a check. Now, we've got to work out the float. So if we want to work the float out, it's identical to what you've just looked at. So for activity 5 over here, the float is the latest finish minus the earliest start, which is 18 minus 14 minus 4, which is 0. So no float. There's no leeway. The same will work out for these. The only one that's got a float, because we worked it out, is activity 3. For activity 3, the float is latest finish minus early start equals 14 minus 3 minus 6 is 5. We have got 5 weeks of leeway here. You can move this around by 5 weeks. to suit yourself. You can delay the delivery of materials of this one to ease your cash flow if you want to, spread your labour out, but this one here can move around. So that's the one that gives you the flexibility to adjust. And that's the end of that very, very short little lecture. There'll probably be a part 2 as well coming.